Mike Barley here. This is part 2 of our series on conduit bending. This next section goes through chapters 5 through 7 of our Conduit Bending Lab book, which you can purchase by going to our website at electriclab.org. And let's get started. Okay, so now we're going to get into the bends themselves. So section 10, the 90-degree bend. The first bend to be addressed will be the 90-degree bend. When making this bend, the issue of take-up must be recognized. Bend or take-up is the length of conduit that is taken up in the bending of the conduit. This amount is subtracted from the first measurement stub-up length when making the first bend. The take-up for bending varies depending on the conduit size. Take-up for half-inch EMT conduit is 5-inch. Therefore, to bend a stub-up at 11 inches, for example, a mark is made at the 11-inch point, then measure back 5 inches. Then place the arrow mark on the bender at this point. Here's another example. So we're making a 15-inch bend, a little simpler measurements, we'll say. 15-inch stub up. So we measure 15 inches, and then we'll, of course, take the tape measure and measure back 5 inches. Make your mark at the 10-inch point, and that is where you will place the arrow on the bend. Keep in mind, I'm making emphasis on that. We went over the different markings on the bending shoe. The arrow is where you're making your 90-degree bends from. And here's the shoe itself. You have the arrow right there on. This is an ideal bender. Depending on the bender you're looking at, it's going to be generally in the same location. I've noted that the Milwaukee bender has a arrow that looks a little different. It's more like a slash mark, but you can tell that's the marking that you're looking for when you're doing that bend. Check your bend by measuring from a flat surface to the top of the stub and confirm your bend is accurate. That's how, exactly as shown here in the slide, that's how you determine if your bend is correct or not. Moving on to the gain. A curved bend requires less length of conduit than a square conduit. The difference in length is called the gain. The gain is the distance saved by the arc of a 90-degree bend. The amount of gain depends on the size of the conduit and the radius of the bend. The larger the radius, the greater the gain. A gain table is provided below, and that's what we're looking at here. So conduit type, your half-inch EMT, 3/4, 1 inch, or 1 1/4. Your 90-degree gain is going to be listed here on the right-hand side. 2 5/8 for half-inch, 3 1/4 inch for 3/4, and so on and so forth. By knowing the gain, you can cut the conduit to fit before bending it, and that's exactly what we're demonstrating here. Consider the scenario below. A half-inch EMT conduit with a 12-inch and 18-inch measurement between boxes is shown. The chart shows the 2 5/8 inch would be subtracted from the 12-inch plus 18-inch equals 30 minus the 2 5/8 of an inch for a total of 27 3/8 of an inch. So if you were to do that, cut the pipe to that point, measure it, and make the bend, your pipe should fit in there like a glove. Section 11. Now we're going into the next bend, the 90-degree bends, back-to-back 90-degree bends. So the next bend will be the back-to-back 90. A set of back-to-back 90-degree bends is the distance from a point on the conduit to the back of a 90-degree bend. The first bend in this scenario will be the initial 90-degree bend as described in section 10, of course. Next, we must determine the distance between the first bend and the second 90-degree bend. These bends could be in a U shape or be in opposite directions depending on the need of the conduit pathway. And what you're seeing on the slide here is the quintessential back-to-back 90-degree bend. You've got a horseshoe or a U-shaped bend. But those two bends could be going in opposite directions. One could be laying flat. The other one could be going straight up. That bend would still be made the same, except you have to position the conduit correctly in the bender to make it go where you want it to go. A lot of conduit bending is determining the positioning of the pipe in the bender prior to making the bend. That's why a lot of our bends, for example, in the book, you have QR codes that will lead you to someone making that bend. And it's, the measurements are important, don't get me wrong, but positioning the bender, the bending shoe and the conduit in the pipe correctly is typically how a lot of the mistakes are made. If you don't get it right, of course. So to determine the second bend, a measurement must be taken from the outside of the first bend to the distance required to position the second bend correctly. The first bend must be from the arrow, and the take-up, 5 inches for ½ inch, must be considered. So you make your first bend, then you've got to take it from the arrow, take your 5 inch for take-up, and you got it. Now notice in this slide, first of all, the positioning of the bending shoe. And this is where this bend can be made, and I've seen made wrong several times, when they did not position the bending shoe correctly. Notice it gets flipped around and it's in the opposite direction. The second bend must be done using the star point. No take-up is used when bending from the star point. So the first bend is made at the arrow. When you're making a second bend in a back-to-back 90 setup like this, you're going to use the star point on the bender rather than the arrow. The bending shoe must also be positioned as shown. So, bending example here. ½ inch EMT conduit is installed and requires a 15-inch stub up. A back-to-back 90-degree bend is also required. The distance between the two bends will be 30 inches. Using a 60-inch ½ inch stick of conduit, this should leave a ½ inch stick of EMT conduit, should leave a 15-inch stub up at each end. Offset bends. This is where we get into a few different types of bends. Offset bends are 90-degree bends, and offset bends probably some of the most popular bends. Offset bends, obviously, you're overcoming an obstruction is what you're doing when you're making offset bends. Box offset bends. The bend made when a conduit is entering an outlet box is commonly called a box offset. These bends can be made very quickly and require little prep work. It is best to use a 10-degree or 22.5-degree angle for the bend. Measurement is not typically needed. The first bend can be made approximately 2 inches from the end of the conduit. Using the degree marks on the bender at 10 degrees, make the first bend, then turn the conduit upside down and slide it forward away from the bend, or away from the end, entering the box so that it is just beyond the first bend. Make a second bend matching the first 10-degree bend, and this should position the conduit at just the right height so that it enters the connector and both bends are parallel to each other. So basically down here on the left-hand side in the lower corner, that's exactly what we're looking at. You're trying to get up into that box. If you're running conduit and you're using mineralac straps or standoff straps, as they're also called, typically you don't have to make this, as the strap will put it at the right height where it'll enter right into the knockout into the box. But if you're using one-hole straps and you need to keep the pipe close to the wall or whatever the surface is, then you would use a offset bend like this to get it into the box. Otherwise, your pipe's going to be coming in at an angle. It's not going to appropriately enter the box. Now, note, this bend can also be made with a box offset bender. These benders, although expensive, can be a time-saving tool. These are great. I've used them many times. I think they're probably $200 or $300 for one of them, but they certainly can make offset bends very quick. Now, for the standard offset bend. One of the most used bends is the offset bend. From small offsets entering an outlet box to navigating over large obstructions, bending this type of bend accurately is of extreme importance. An offset bend is two opposing angle bends designed to clear an object in the pathway the conduit is being installed in. The first thing that needs to be recognized is the offset table. And this table's in the book. You'll also see this. We'll talk about it in a second, but you'll see it on the handles oftentimes of benders. But as you can see, we have the angle of the bend down the left, the multiplier that you'll be using in the center, and then the actual shrinkage per inch of the offset bend. And across the top, that's your calculation. So the offset depth, so you need to know what the depth of the offset needs to be, times the constant multiplier equals the distance between the bends. When an obstruction is encountered in a conduit run, the installer must assess the best pathway to navigate around it, over it, under it, to get beyond it. This must be done considering the more degrees of bend in a conduit run, the more difficult the wire pull will be later. The easiest conduit to pull wire in is straight. Minimizing the degree of bends is a major concern. So shallow offset bends 3 inches to 4 inches in depth, a 30-degree bend will be ideal. An example again, the offset depth times the constant multiplier equals the distance of the bend. So 4 inches depth, go to your table and find your multiplier, which is 2, so that's going to be 8 inches. So you're going to have 8 inches in between the bends. Now, at the bottom here, note, you will use the arrow mark for your bends. Offsets 5 inches deep or more. A 45-degree bend is best. The multiplier from the offset formula table is 1.4. Therefore, in our example, 5 inches depth times 1.4 is 7 inches distance between the bends. So you're going to have 7 inches between the two bends. And as you can see, as you're designing these runs, the least amount of bends, the better. But you can make that degree determination, and just depending on structurally what's in the way, what it's going to take to be able to get the pipe in where it needs to go. If you have an object with a height of 10 inches and used a 22.5 degree angle, you would calculate it as 10 inches times 2.6 gives you 26.1, which would be converted to 26 1/8 inch distance between the bends. It is expected to round the decimal numbers to the nearest eighth of an inch or a quarter of an inch. And shrink per inch of the offset depth. When an offset is bent in conduit, the conduit will decrease or shrink in length because of the angles used in the bend. Notice in the table below, for each angle listed, there is an amount of shrinkage applied. And of course, all the way to the right, per each bend, it tells you exactly what that is. For example, a 30-degree offset is being used, and the bend will start 10 inches from the end of the conduit. Per the table, this will result in a shrink of 1/4 inch per inch of offset height. So if an offset was 7 inches, this would mean that 7 inches times 2 gives you 14 inches between the bends. And 7 inches times 1/4 equals 1 3/4 inch of shrink. So you'll start the first bend at 1 3/4 inches ahead of mark Y. So you can see where our markings are here, 10 inches at the mark X, coming from the end of the conduit, and then 25 3/4 inches at mark Y. And note that this particular bend, as all bends in this book, are done on a 60-inch piece of conduit. We did that so that when you're obviously using up quite a bit of pipe in the lab, you don't waste pipe. All right, and next is the dog leg. What do we mean by that? A dog leg happens when the two bends of an offset are not aligned. When making the second bend, be sure and look down the pipe or sight like a rifle and make sure you are going to bend the second bend in the same plane of the first bend. This is the common mistake, is either you've got it a little bit out of line or you've got it backwards, one of the two, and then your bend, you waste the pipe and your bend ends up being incorrect. Now we're bending an offset bend. Make that first bend, moving the pipe forward and making the second bend. So what is a 4-point saddle? Basically 2 offsets. Once we understand the offset bend and how to rise above an obstruction, we must address the scenario of how to come down the other side. A 4-point saddle bend is the same as 2 offsets in a conduit run. This type of bend is used when a square or rectangular obstruction is in the pathway and a smooth transition up and over is needed. The same principles are used in these bends as given in the previous section for a basic offset. The best angle to use is the 30-degree. We will use this in our example. And then we've got some measurements down here, 10 inches from the last coupling or the last junction box, whatever the case may be, the last point. And then you have a 4-inch tall by 10-inch wide obstruction. So 10 inches from the last coupling. Because a 30-degree angle is being used, the shrink will be 1 inch. So 4 inches times 1/4 inch equals 1 inch. The distance between the bends will be 8 inches. Mark the conduit in 4 marks. You can see where they are there. Because the obstruction is 10 inches from the last coupling, mark A should be at 11 inches. 10 inches plus that 1 inch gives you 11. Mark B should be 8 inches from mark A. The third mark, C, is determined by the width of the obstruction, which is 10 inches. Mark C should be 10 inches from mark B. And mark D should be the same as the distance between mark A and mark B, which is 8 inches. So the measurements are shown here below. Mark the conduit in 4 marks. So in the first bend is made at mark B. That's a big note here. We just looked at an offset earlier, and the first bend would be considered actually at mark A. When you're doing a 4-point saddle, we're starting at B. Place the arrow on mark B and bend to 30 degrees. This bend can be made on the floor or with the shoe up. I think oftentimes you'll see this demonstrated as the first bend being made on the floor. So second bend, slide the conduit to mark A and do not remove it from the shoe and rotate it 180 degrees. Use the arrow for this bend also and make the bend to 30 degrees. In the third and fourth bends, remove the conduit from the shoe and turn it around so the completed bends are in front of you. Using the arrow again, slide the conduit to the mark C and make the bend to 30 degrees. And then the last bend, the fourth bend, do not remove the conduit from the shoe. Slide it to mark D using the arrow. Rotate the conduit 180 degrees and align the conduit with the other bends. Make sure they are straight. Making our first bend, that's at mark B. And making our second bend at mark A. Our third bend at mark C. And then our fourth bend at mark D. That was 4-point saddles. Now let's look at 3-point saddle bends. The 3-point saddle bend is made up of 3 dimensions. They are typically used when clearing an obstruction such as a water pipe, vent pipe, or any round object in the pathway. They are used for obstructions less than 7 inches. Proper procedure must be adhered to for the bends to turn out correctly. Orientation of the bending shoe for each bend is crucial. These bends are made using 30 degrees and 60 degree bends or 22.5 and 45 degree bends. Using the 45 to 22.5 degree angles makes for an easier pull when installing the conductors. And as we've said, the less bends, the less degree of bends, the easier the pull. And here's our formula table. Make sure that you're using it to determine your distances. The distance from the last conduit coupling to the obstruction in our example is 30 inches. In our example here, we will use a 45 degree and a 22.5 degree bend. Our obstruction will be a 4-inch pipe. Therefore, 4 inches times 2.5 gives you 10 inches. And the shrink per the table will be 3/4 inch. Next, we will need to mark the conduit. The first mark A will be the distance from the coupling to the center of the obstruction and considering the shrink. So the mark A would be placed at 30 plus 3/4 inch for shrink, gives you 30 3/4. Mark B and C are made 10 inches from mark A. And this is what we're looking to achieve right here. This is our 3-point saddle. And as it shows here, check the height to the bottom of the conduit. You know, once you're done, you can get it on a flat surface, take a tape measure or got a folding rule we're using here, and that's how you can check to see if your bend is accurate. The bends are made at the rim notch or teardrop for mark A, and marks B and C are to be made using the arrow. And there is where the mistakes are made. You get the wrong marking. I have this happen all the time. I have students come up and they use the wrong markings and they're just like, I don't understand. What happened? Why my bend is wrong? Well, possible orientation incorrectness of the bending shoe, or you use the wrong mark on the wrong bend. Here is another slide showing the bending sequence. You know, you're starting with the bend in the middle, and then notice the orientation of the bending shoe. That is key. So the first bend is made at mark A using the teardrop or rim notch. This indicates the back of the 45 degree bend. Position the bending shoe as shown below and bend to the 45 degree mark. The second bend is made by sliding the conduit to mark B and using the arrow with rotating the conduit 180 degrees. Using the bender in the upright position, put force on the conduit by using your armpit and bending to 22.5 degrees. Be sure that you are aligned to the first bend appropriately. And the last bend. Make the third bend by removing the conduit from the bender and reinserting it in the bending shoe from the opposite direction. The bends from you have already made should be in front of you. You never want to bend across bends you've already made, because you do that, especially with 1/2 inch, you're going to more than likely negatively affect those bends you just made. You're going to take bend out of them or something to that effect, and it's going to mess your bending up. All right, start with our first bend in the middle, the 45-degree bend. And here's our next bend. And then flipping it around to get our last bend in. A compound 90-degree bend occurs when a conduit enters a corner that has an obstruction in it and the raceway cannot follow the contour of the wall. This technique works for any combination of angles. Use a folding rule or tape measure to determine the proper combination of angles to use for each bend. In our example, let's say the measurement between A and B is 12 inches. Make the marks on the conduit for these points. First bend, using the rim notch, bend to the 45-degree point for mark A. And then second bend, using the rim notch, bend to the 45-degree point for mark B. Okay, next we're getting into Introduction to Mechanical Benders. Now let me say this. Mechanical benders basically are a hand bender with a ratchet on a stand. Best way to put it. So a mechanical bender, aka Chicago style bender or a ratchet type bender, is a manual conduit bender like a large ratchet. One of the first manufacturers of this style bender was the Linseed Company of North Carolina Incorporated. They originally started their business in Chicago, where the bender was developed, but later moved to North Carolina in 1955. They named their bender a Chicago bender, and the name has been passed on for any mechanical bender of this style. Despite most commonly being referred to as a bender for rigid conduit, there are several brands on the market today that will bend EMT. The one shown here, this is one made by Southwire. This is what we use in our labs, and it is a bender that you can get shoes that bend from all the way down to 1/2 inch, as a matter of fact. They have that available. Why would you want to use one of these benders? Well, it's going to be, I believe, it's going to be more ergonomically easier for the electrician to be using one of these types of benders. I think that you can probably bend with more speed. And from a teacher standpoint, I have seen bending accuracy increase when my students move forward from the hand bending to start using the Chicago style benders. Although these benders are more expensive than a hand bender, they can produce more bends in a given amount of time than hand benders, and it can yield very accurate bends with less physical exertion on the part of the user. These devices do not require electrical power, but rely on the ratcheting action to create the bends. The markings include a bending degree indicator and typically tables and diagrams showing how to make the conduit bends. It is good practice to calibrate the bender prior to bending to ensure accuracy. And bending with Chicago style benders is much like hand bending. And I'll say this because we don't do as much in depth in the book regarding the Chicago benders versus the hand benders, because I believe of the similarities in it. I also must point out that if you're using a Southwire bender, or maybe you're using a Greenlee bender, or whatever brand of bender you're using, there's most certainly going to be nuances about that bender that would be different from another bender. So you really have to familiarize yourself with the brand that you're using. But generally speaking, they're very similar to hand benders. So, making stub-up bends with mechanical benders. The example here is make the necessary marks for an 18-inch stub-up with 1/2 inch EMT conduit. Be sure and confirm markings on the mechanical bender are consistent with this practice. Take up as required per the manufacturer. Note, exercises are included in this book for lab bending. However, it is not manufacturer specific to a brand of device. Be sure and assess the tables and requirements of the device you're using. I believe I just pointed that out. Exercises are included in the lab book. You'll need to correlate the brand bender you have with those exercises. So, section 17, example, making stub-up bends with mechanical benders. Got the pipe in the bender, ready to make it. Notice his foot positioning there to kind of hold himself in place. Okay. Next, we're going to veer off into a different type of conduit. PVC bending. Polyvinyl chloride. So, rigid polyvinyl chloride conduit, also known as PVC, is commonly used for installations underground, wet locations, corrosive environments, and in general where a metallic conduit would be a problem. Schedule 40 PVC is a thinner wall conduit and can be used below grade, but above grade must be Schedule 80. And there's actually an NEC tip on there. I believe there's a height once you get up a little bit higher. If you're running on the outside of a building, I think you can go back to Schedule 40. The NEC states that all field bends must be made identified bending equipment. And this equipment can be the following. What you have here, these are what are called hot boxes. And a Greenlee brand on this one here. You can get them in a variety of sizes. The one I have in my lab is the one on the left. It's a larger one. I believe it would bend, at least up to 4-inch. Heating the PVC conduit. To bend PVC conduit, it must be heated. To do so, a hot box is one of the most common methods. The conduit is placed in the box and slowly rotated on rollers inside the box so the heat is evenly distributed. Failure to rotate will result in burning the pipe, which will give it a burnt hot dog look. Everybody's probably seen that before, which some inspectors will fail installations because of. When the pipe becomes flexible, it is removed and shaped to the desired curvature. It's also very hot. Then it must be cooled, which often is done with cool water, rags, or just waiting. Hand or mechanical benders can be used in this forming process to bend and hold the conduit in the form intended until it is cooled. Care must be taken not to allow the conduit to flatten at the bends, which would be considered damaging and reduce the area of the inside of the pipe. Obviously, you're always protecting that real estate that's inside of that pipe, because that's determining how many wires you can get in it. And just here's a couple of shots of a variety of different types. You have at the top left, you also have a heat blanket. On the right hand side at the top there is a heat gun. You can use those also. What's not shown here, and I've seen this done also, is using like a hand blowtorch. That's a good way to get the burnt hot dog look. But I've done that before in a pinch. And there's another shot of the heat blanket. It's also pretty easy with a heat gun like that to get burnt marks on the pipe too. So you just have to be careful with it. Bending PVC conduit. So before attempting to bend the PVC conduit, first plug in and allow the heater unit or the hot box, if that is the method used, to warm up. Another aid that can be used is PVC plugs. You're basically going to put these plugs in the end of the pipe, which will help it aid in keeping it from collapsing. These devices are inserted in both ends of the conduit, which will cause heat to be held inside the pipe and result in a quicker temperature rise. Additionally, this will aid in keeping the conduit from flattening or collapsing. Once the heater is hot, insert the conduit. Rotation must be continuous until the conduit is completely flexible and ready to be formed into a bend. You must act quickly, as the conduit will cool down much faster than it heats up. Forming the conduit into offsets, kicks, or even 90-degree bends can be done at this point. Use the same rule as bending other types of conduit, although, for example, if bending half-inch PVC conduit, you will use a 3/4 inch EMT bender and apply the rules of that bender to your bend. Okay, so now it's time to apply what we've learned. So let's get out in the lab and see if we can make some perfect 90s, some offset bends, some box offsets. Let's see if we can bend some conduit with some accuracy.